Hello and welcome to the second lecture in seventh chapter of our comprehensive course on AI, ML and DS. In first lecture we discussed about this thing, that what is the need of doing data wrangling, and I gave you one example of unclean data set, and I said that using unclean data set one cannot obtain a model like this. For obtaining model, first condition is that you have to understand the data, you have to clean the data. That is also called data pre-processing. So EDA includes actually not only data understanding, but it is also inclusive. It also includes data pre-processing, and pre-processing is what? That is what we are going to learn in this chapter. And this is called feature engineering, and then you can do the next stages. And when you create this model creation, that model is itself this model, right? So such equation you can obtain, but not mathematically, but using the past data. Okay, that is the job of data scientist. Now, I also gave you one example of an unclean data set, and for creating that data set, I used this kind of code. Now, you may wonder from where I have brought that code, but actually I have done nothing, and this is the another say one application or use case where the AI tools are very useful. For example, here this create a all-in-one example, and here I have written one prompt like this, that you create a pandas data frame, and maybe I think here it is not saved. Okay, fine. So I will have to copy paste first in a notepad and remove all this initial hash tags. Okay, so here I am copy pasting and I will remove all hash. Okay, so I copy pasted. Now this becomes my prompt: create a pandas data frame with 100 rows and following columns. The columns are first name, SSN, gender, age, income, education, and the column should have following characteristic, or the data frame should have following characteristic. One, there should be 12 duplicate rows. There should be 4 rows in which outlier values of age should be present, like 140 years age, 170, 190, 220. There should be 7 invalid rows in which either age or income or both must be negative. Then there should be just a minute. There should be some null values, these many null values respectively in this column. So first name has 5 null values. Last name column I just removed afterwards because I did not want to keep my data set very wide. So say 3. Then SSN has 4 null values. So null means empty, and so on. Then SSN column must be randomly filled with 12-digit numbers. Social security number. Gender column should be filled only with male, female, and other. So that is like that np.choice which we used, and the probabilities must be 0.46. So 46% of my sample is males, 53% of the sample are female, and 1% are others, maybe transgenders or maybe someone who does not want to identify the gender. Okay, then age must be between 20 and 60. Income must be random integer between 3,000 and 12,000. Say it is monthly income in dollar. Education must be filled with choices only between these: graduate, postgraduate, doctorate, postgraduate, graduate, and undergraduate. And the probability is also this: 10% doctorate, 30% postgraduate, 20% are graduate, and 40% are undergraduate. There should be 3 rows with gender, not from this. Earlier I said that gender must be male, female, and other, but now I am saying that there should be 3 rows which have invalid value of gender, but some means the user maybe they did not want to disclose the gender and therefore filled up some random value like alien and all that. Then there must be 5 rows in which education is not from this. So this some users did not obey this instruction, and they wrote some again strange values for education. Okay, so the education was not from that. Okay, now this is my command, and you can see I want to create a pretty complex synthetic data set. But if I just message set ChatGPT, and remember I have not even logged in, so I am using just free version of ChatGPT, and I just give this prompt, and it is very quickly generating the Python code. That if you want to create that kind of data frame, then use this code. So this is one another great application of large language models or chatbots, that whenever you want to generate fake data or maybe some data which is only for research purpose, synthetic data, then just use free model. Here there is no harm in using free model because the whole data itself is fake, and there is no question of any protection of privacy or violating the privacy rules or anything. It is just a fake data for my academic exercise. So I got this kind of code, and when I execute that code, I will get my data frame. However, there is one issue, that normally if this many large number of rows are there, 111 or so, then the output will not fit. So only top 5 will be seen, then some ... and then bottom 5. But here I have set some options earlier. So in one chapter I told this, that there are certain options. These are called environmental variable. So you have to write pd.set option. First you have to import pandas, as PD. So this sentence should be here. Okay. So PD dot set option. Which option? Display dot maximum rows. So that means option is related with the display, and in that also it is related specifically with maximum rows. And you specify maximum row none. None means no maximum row, or you don't specify anything, no limit to the maximum row. So even if your data frame is say 10 lakh rows, then it will try to print all those. Of course 10 lakh rows will become so big that sometimes it goes beyond the memory capacity of your hardware or Jupyter, and at that time some error will come, but it will be able to print any number of rows. We are saying none means no maximum rows. Okay, similarly this is display maximum columns. Now that is used sometimes when the data set is very wide. So if there is wide data set, say there are 100 columns. So exactly same thing what occurs for row that will occur. Say first 5 column will it be displayed, and here some dot will be there, and here in this region some last 5 columns will be displayed. So if you don't want that and you insist that I want to view all the columns, then write again PD dot set option and display dot max columns equals none. Max columns not equals but comma none. Okay, and similarly if you want maximum column width, now that is sometimes what happens is this this each row, one particular column can be very means large number of characters. For example, one column is there. You are doing your employee survey, and employees are asked that open-ended question that do you have any suggestion for my firm so that I can improve the employee engagement. Now employee may go on giving suggestion, and it can extend over maybe 300 words, 400 words like that. Okay, so at that time the column width will not be able to accommodate all, though the data frame will be created, but in the display you will see only limited initial few words, not all 400 words in the column. So there, if you want to solve that problem, then you can write display dot max column width. Still, of course, that will be limited to the width of your screen. If your screen cannot accommodate, then nothing can be done. But it will try. Jupyter will try to print entire column on the screen. Okay. So these are the three options. And now, if I want to set back to the original behavior, then I just have to remove that none. Okay. So if I remove that none and re-execute this, then you will see that it. Okay, there is some issue with. Maybe I have to provide some numbers. Okay, so maybe I just provide 20, and maximum columns also I just provide say 10, and maximum column width also I provide maybe 10. Okay, and then I write. Now if I again execute this, then you will see that since I allowed only 20 rows here this 20 rows, so therefore it says that print first 5, print, it goes to its default behavior, and below of course it shows that there are 112 rows and 6 columns, but it goes to default behavior that's showing top 5 and bottom 5 rows. Okay, so this is about that option, and one should learn that option because sometimes the anomalies are hidden in the in between rows, and if in between rows are not visible to you, then you will not be able to view them, and you will not be able to detect them, and then the question of cleaning them will not arise. So I am again putting none, and now you can see I am getting all rows. Okay, this I shifted upwards because I want to always keep this example in front, and I want my discussion to repeatedly refer to this. So I did not want to scroll all the way down to bottom of Jupyter notebook. Okay, now, but this is one great application of ChatGPT creating synthetic data. Okay. Now, introduction to data wrangling. That is what we are doing now. Okay, so data wrangling, which is also called data munging, is the process of transforming and mapping the data from one row into another format that is more appropriate and valuable for analysis. Okay, so this involves, because this kind of data which was there here, this is called invalid data. I cannot get much out of this. Many of the rows have none, many of the rows have invalid value, but I have to convert it into format which is more appropriate and valuable for analysis. So this is called raw data, raw. But I don't want data. Data science is not about data. Data science is about deriving insight from the data that helps in making a business decision. So that's why I earlier also said that better name for data science would be decision science. Okay. Now this involves cleaning, structuring, and enriching the raw data. So this kind of raw data is there. So first you have to clean. Clean means wherever maybe duplicate rows are there, you remove them. Wherever outliers are there, replace by mean or median. Wherever invalid values are there, for example, gender, alien or unicorn, so then you have to replace it by some mode or the most frequent gender which you find in your data set. So that is called structuring and cleaning your data. And enriching. Now enriching is also important thing. Enriching means what happens is sometimes you get very less number of observations, and at that time you can use two techniques which are called one technique which is called oversampling. So if I have suppose only 20 observations, but you will see later on that 20 is a little bit too less number to get any statistically significant insight. So what we do is we use those algorithms. One of such algorithm is called random oversampling. Another is called SMOT, SMOTE. We use those algorithms and they will add some desired number of observations which have same characteristics as the 20 which are given. We don't want to add any random 20 observations. Suppose I add 20 more rows and all of them are male in gender, or all of them have income 10,000 only, then I am not capturing the essence of my already existing data. So I want to add 20 more rows, but at the same time I want that those 20 more rows should capture the essential traits or characteristics of my already existing data. Then these algorithms are so powerful that they take care of that. So that type of phenomena is called oversampling. So sometimes you need, when data is very less, you need to enrich the data. Enriching is not only in terms of number of observations, but enriching is also in terms of adding new features. So here that diagram was there in which feature engineering. For example, your data set has some patient's detail and it has maybe weight and height in meter. But you can think that weight and height individually are useful, but instead of that, if I write weight divided by height square, so then that is BMI, that will be more useful. Similarly, if it is cardiologist data and the person has saved hip ratio and waist ratio, hip length, that is hip circumference measured by a simple tape, and waist circumference. Then for predicting heart disease, it has been found that the ratio of waist to hip or hip to waist, whatever way you take it, that ratio is very important predictor. It is more important, in fact, than the BMI also. So then that is why you can enrich the data. Enrich means you can add new features. Okay. So this process of cleaning, structuring, and enriching raw data to make it a valuable resource for decision making is called data wrangling. Data wrangling is crucial step before analysis, and the quality and structure of your data will greatly impact the result of any analytical model. There is the well-known saying in the data science, garbage in, garbage out. So many people do that as soon as some data comes in their hand, they will try to divide into train set and the test set and build a model. But if their data is not of good quality, then the model which is coming out of that data, that will also be of not good quality. Okay. Here, this process of data wrangling, in fact, entire data analysis cycle is shown, but a very simplified diagram. I prefer this diagram because nowadays a lot of expectations are added in data scientist profile. So this is the complete full stack data scientist work. While this was originally what data scientists were expected to do. Okay, so expected to do was they were expected to ask right questions, and it is a little bit not good quality diagram. So apologies for that. Then if they are asked to ask the right question to the business stakeholder and understand the business problem and convert it to data science problem, they are expected to then data wrangling. Okay, the purpose of showing that is that analysis comes much later, but data wrangling is a long process and it takes more time also. Okay, so discover the data, structure the data, clean the data, enrich the data, validate the data, and then publish the data. Publish means use that data for model building, and then that model building and analysis and all that come. And this bulb-like symbol finally says derive insight from the data. For example, that customer said that I have 4 marketing channels, and which way I should allocate my budget. If you give him clear-cut answer that allocate this much money to social media and this much to TV and this much to radio and this much to newspaper, and if you follow your recommendation and next year his sales and profit jump by 10%, then he would be happy like anything. So what you are giving is that insight. How should he? What he brought is just raw data and his problem, and what you are giving is that insight. All the intermediate stage, the client or the customer should not need to bother. Okay. Now this is common operations in data wrangling. One, handling missing values. Now as I showed earlier, here this none is there. So person did not specify his whichever that column is age. Okay. Here in the gender also there may be some none or it is not there, but income perhaps yes. So many person maybe deliberately left that income blank. So there is that is called missing values. So what to do with that missing value? That is one thing. Then data type conversion. Now sometimes what happens is that this income, okay, Now, ideally, I want that this should be either integer or floating point number, but it should be a number. But there may be some person who has written 10 TEN 10,000 THOUSAND dollars. Now, obviously, that will not go with other observations. So you will have to convert its data type from string to other. Sometimes just randomly also. See this all these are string data type, postgraduate, undergraduate, or here also name. The name usually does not affect, but gender, maybe male, male, female. Now, most important thing about machine learning is that machine learning understands numbers only. So machines understand number, so you have to convert this male and female into some numbers, like maybe male is equal to 1 and female is equal to 0, and then male, so all these values will be converted into 1 1 0 1 1 0, like that. Similarly, here you can give some four code, because there are four values in my original I have given. Others are just garbage values due to unclean data. So I can give doctorate is 1, postgraduate is 2, graduate is 3, undergraduate is 4. Okay, so that is that process of converting the data type from string to numbers, that is called encoding. So I have to convert the data type. Okay, that is one requirement. So first, handle missing value. Next, data type conversion. Third, outlier detection. Now outlier detection is also required. For example, in this only income. Now many income are negative. So obviously I know that person cannot have negative income. Okay, so that means that should be removed. Then in age, some ages are 220 years age. So that is minus 1 year age. So these are called outliers, and in this case, I have to replace them by mean or median depending upon whatever is my strategy. Okay. Then outlier detection, then duplicate detection and deduplication. If there is entire row which is duplicated below it or above it somewhere in the entire data set. Now think about that. It is not necessary that the duplicate row is exactly below or exactly above. It might be that there are maybe 1 lakh rows and duplication has occurred in 10th row and 20,455th row and 80,949th row. Now, if you manually try to scan each rows and find which 3 rows are duplicates of each other, that is a very tedious and unfeasible exercise. But Python, Pandas, just by one function, duplicated, and it will give you sum of duplicated rows. So it will give that how many total duplicated rows are there, and you can even find them by, we have seen how to find a particular row by either iloc or loc. So you can actually find that which index, maybe that third and 8,433rd and 19,949, like that. So that is there. Then identifying and dropping single value to column. Now that is also pretty important, because ultimately what is the basic thing about data science, you want to study the variation in your response variable or the dependent variable with variation in independent variables. Okay, like this. Fine. Now variation in the response variable, so this must be a variable in first place. If your TV marketing budget for all observation is not changing at all, then obviously its effect on sales is also nothing, because it has no value. That data has no value as far as TV marketing budget is concerned. What I'm saying is, suppose all the genders are male. Now, in that case, if someone asks what is the effect of gender on the outcome, say income is the outcome variable or response variable, what is the effect of gender? But if everybody has male gender, then that means that my data can never tell what is the effect of gender on income, because every observation has one gender only. So gender is not variable at all, but it is a single valued column. It is a constant, so it will have no effect. Okay, so then that is called identifying single valued column and dropping such columns. Such columns we simply drop if very rarely you find such columns. Then normalizing and standardizing data. Now that means what? Then you have to think whether all the columns are of same scale. For example, this age was between 20 to 70. It is a different thing that some very large value 220 etc. came, but more or less it was less than 100. While this income is between 3,000 to 10,000 or 12,000. So you can see that incomes are over a large scale, 3 to 12,000, while age is 20 to 70, a small range. Now, sometimes what happens, there are certain models which don't care whether what is the range of a particular column, whether it is a large range or a small range. They do not care means they give accurate result, and there is no need to do anything with the data. But there are certain algorithms which have a weakness that if large range income like column is there, then they disproportionately make its effect disproportionately high on the response variable. Here income itself is my response variable, but suppose here some other response variable may be there, that whether the customer has churned or not, that is whether the customer has left or not, and I want to understand what is the effect of income, gender, etc. on customer, on the chances of a customer leaving my company or going to my competitor company. So in that case, this income will dominate much more than age, because age is only 20 to 70, while income is 3,000 to 12,000. Big numbers are there, and some algorithms cannot take care on their own. Okay, so that time what we do is normalization. Normalization means we do something, and what is that something is coming in this chapter, but we do something so that both come in a particular range. Say age also comes from -1 to 1 or 0 to 1, suppose, and income also comes from 0 to 1. Okay, still they maintain the original data distribution. Now how to do that, we are going to see later on. Okay, fine. So what is done in data manipulation? Six things: handling missing values, converting data types, maybe string to numbers because machines can understand only number, deduplication, outlier detection, unusually high or unusually low values are called outliers, duplicate rows are called must be removed or something must be done to them, single valued column must be removed, and finally all columns must have same scale. There should not be very large or very small because it is crucial for many machine learning algorithms. At the same time, there are certain algorithms and most modern algorithms, like for example random forest or XGBoost, many don't care, and that means that you can avoid the step of that scaling or normalizing. In some algorithms you have to do that. So that is also the knowledge which a data scientist must have, that if I am using this algorithm, whether or not I should scale the data or not. Now let us take each of these one by one. So first is handling missing values, and this is the example. So we will do it in next